talk about decomposition reactions today. All right, and we just did composition. They're going to be pretty much the opposite, right? Composition, you put things together, you compose them. Decomposition, we're going to break them apart. Now, I'm going to move my camera over here so people who aren't here can see this. Those of you who are here can see that this stuff here, all I've got in there is basically water, and I'm passing electricity through it. And you can see at the top there, we're collecting some bubbles, okay, of some kind of gas. We're going to figure out what that gas probably is. If all I've got in there is water and I'm passing electricity through it, what do you think that gas probably is? What's water made out of? Hydrogen and oxygen, yeah. All right, now, this is a very delicate little apparatus. You can see how old it is. So I'm going to try to put it in the sink out of the way so it's not blocking you guys' view. However, I also want to let it run because I have to collect enough of this to be able to do something with it later. All right, so I'm going to move this gently, probably screw it up, but I want to put this into the sink so that's not in everybody's way. But I still want it to be running. Let's see. Oh, good, it's still running. All right, we'll look at that at the end of the period because it's going to actually get to, we're going to talk about that particular type of reaction. Of the decomposition. Because if you look on your common ion sheets, and your common ion sheets in the middle, you already talked about composition reactions. Now we're going to talk about decomposition. There are 6 of them. All right. I have a couple of things I want to do with these. I'm going to do examples of each. I'm going to do a demo, this one here, and another one I have a little video one because it's a little bit too dangerous, as you'll see. Okay.
These things explode.
What's that?
These things explode.
Yes, but again, you could ask that question every time, and you will. Or can we eat it? What will happen if we eat it? Can we drink it? Will I die if I drink it? Are we going to blow anything up today? How many questions are on the test? How many points is this worth? All my favorite questions. All right, take a look. Turn that light off, and we'll do a little bit of the video here of that demo. You ratchet? Do not try this at home. Potassium chloride is one of the guys who I am going to do a decomposition reaction on. Now this is technically not because they're going to add something to it. All right, but basically, the reason potassium chlorate is dangerous, you heat it up here, it's a very strong oxidizing agent. And it will, just by heating, decompose. All right, one of the products is going to be oxygen, as you'll see. But watch what else happens when you have any organic material around potassium chlorate while it's being heated. A little cube of sugar here. Needless to say, we're not doing that. Dang it. Thought I'd just show it to you. Turn that backlight on for me.
Why can't we do that?
Because I don't want to kill somebody.
Wait, do we have potassium
We
chloride?
can do it on the side.
Yeah, oh, absolutely. We have potassium chlorate in the back. We're going to do some of these. One of these in particular, we have a lot. Hey, sodium. Remember that sodium that we used for the chlorine one? We're going to do a reaction with that tomorrow. Or actually, not tomorrow. Tomorrow you have a single, right?
Yeah.
Tomorrow you're going to do the worksheet. All right. On Monday we'll do a reaction probably with sodium. So yeah, we have a lot of dangerous stuff back there. We'll talk about some of that other stuff as we get to it. But let's right now talk about decomposition reaction. God bless you. Decomposition general formula. Guess what? AX yields A plus X. It'd be nice if they all were that easy, but they're not. That's just a general formula. If I have a simple binary compound and I break them apart, that's what you're going to get. You're going to break them apart into its constituent elements, the elements that make it up. Okay? So, for example, if I broke sodium chloride apart, and I can turn them into sodium and chlorine again. That makes sense. All right, but those are really easy ones. I'm going to show you how to do some. They don't break up quite the way you'd expect. They don't just break up into A plus X because they weren't just binary compounds. They were ones with polyatomic ions in it. And once again, I'm going to remind you, those guys back there taking a test, you just took it yesterday, of how to draw these correctly as you're doing them. Okay, let's start with well, the 6 types are all on the sheet. And if you were to look at that sheet as I'm doing these, you'll be able to tell me what each of these guys is going to do. Okay? Let's try the first one. Aluminum carbonate yields. Now, let me just ask you. Raise your hand. What do you guys think aluminum carbonate is going to break up into? Raise your hand if you think you know. What do you think, Ben?
Aluminum.
And carbon, and maybe oxygen, or aluminum plus carbonate. Those are the 2 common mistakes that we're going to see all the time. Aluminum carbonate yields aluminum plus carbonate. Or, oh, no, that's right, aluminum carbonate means Al, carbonate CO3. So aluminum plus carbon plus oxygen. No, that's not what happens. And the nice part is you don't have to memorize what happens. Look at your sheet. What does it say under decomposition reactions? Everyone's looking at the sheet. Under decomposition reactions, can you now raise your hand and tell me what aluminum carbonate is going to break up into? Ah. Now, I know I'm going to get another mistake here, but let's try it. What do you think, Ben?
Oh.
Go ahead.
Carbon dioxide.
Well, that's one of them. What else? See, this is a funny thing. Read to me what it says in the sheet. The whole number 1.
Metallic carbonates yields metallic oxides plus carbon dioxide.
Correct. Now, that's the general formula. I'm simply asking that you apply that general formula. Metallic carbonates yield metallic oxides plus carbon dioxide into the specific example. Who's my metallic? Who's my metal in this case? Aluminum. So if metallic carbonates yield metallic oxides, what is aluminum carbonate going to yield? Anyone? Aluminum oxide. You see, it's simply saying on the sheet the generic formula of what's going to happen. And then I give you the specific one. So it could have been sodium carbonate, in which case it would have yielded what? Sodium oxide plus, in both cases, it's going to give you what? Carbon dioxide. Now, if you want to know how I'm supposed to know that, the answer is you don't have to. It's right there on the sheet. You get to use this sheet on every single test like I told you. Once again, just like you kind of already know the formula for some of the common ions, you're going to kind of know these reactions too by the time we're done too. All right? Like, for example, some of you already know, what's the atomic mass of oxygen already? 15.999, you don't have to look it up, right? I mean, there's a lot of that stuff just comes from using it so much. And that will happen a little bit, I hope, with this as well. Okay, so there's your first step. Remember, there's 3 steps to each one of these processes. I finished the word equation. Now I have to write the correct formula underneath each one. Let's do that. Aluminum carbonate written correctly is Al. What's its charge? Plus 3. Carbonate is CO3 minus 2. So to write it correctly, I need a 2 there and a 3 there. And again, notice that it didn't go away. That was the first 13 questions on your last test. We're doing this. It's not going away now, and it ain't going away in the future. Aluminum oxide, Al, plus 3. What's oxygen's charge? Look at the common ion. Look at the periodic table. What's oxygen's charge? You should know it anyway. It's one of the few guys that never changes. It's minus 2. So I need Al2O3. And carbon dioxide. Do I have to look the charges up for carbon dioxide? What is carbon dioxide? O2. Okay? Look, if it's not coming together by now, it should be coming together by now. All right? Because we've been using this stuff and doing this stuff for quite some time. Now, I'm not done yet. I have one last step. What is that last step? Balance. Balance. Right. I got 2 ALs, right? How many ALs do I have over there? 2. You say, well, I have 3 carbon. There's no carbonates over there. No, we look at every individual element now. How many carbons do I have over here? 3. 3 times 1 is 3, right? How many carbons do I have over there? Just 1. So I'll just put a little 3 down here? No. I'm going to put 3 in front. That'll give me 3 carbons. Correct? Uh-oh. Now I'm really in trouble. I can't get those O's balanced. That's tough. How am I going to get the O's balanced now? They're already balanced. How many O's do I have on that side? 3 times 3 is 9. How many do I have on this side of the arrow? 9. 3 times 2 is how many? 6. And 3 is 9. I'm done. Isn't that cool? All right, let's try another one. Calcium hydroxide. Yields. Uh-oh. Oh. No. Oh. We lost one.
It needs a funeral.
Oh.
Where's
I'm playing crappy thing.
I'm pretty sure we could all play Pax.
Okay. So, did you get that one? Calcium hydroxide. What's it going to break up into?
CA.
Ca and hydroxide, right? Just calcium and hydroxide, right? No. Look. Look at people. Again, I'm saying it's amazing how long it takes you sometimes to get the point. These are not the easy ones. The easy ones would be sodium chloride yields. What's sodium chloride going to have to break up into? Because sodium chloride is just NaCl. What does NaCl have to break up into? Na and Cl. Or Na and Cl too, but diatomic, but sodium and chloride. These are polyatomic ions. So they're not going to break up the way you might expect. Look at the sheet. Do you see what metallic hydroxides do? Sure you do. So what am I going to write after calcium hydroxide if you look at your sheet? Common ion sheet. Calcium oxide plus water. Did everybody see where it came from? Number 2 under the. If you haven't figured it out, guys, these are mimicking the sheet. They're following the sheet. 1, 2. What do you think my next one's going to be? Some kind of chlorate. The chlorate, the same one I did as the little video clip. That chlorate, all right, when it decomposes. All right, but we have to finish this guy first. Calcium hydroxide yields calcium oxide plus water. Finish them. What do I have to write? Calcium, Ca plus 2. Hydroxide, it's OH with a -1, so it's CaOH2, right? Got it?
Mm-hmm.
Now, calcium oxide, Ca plus 2, O minus 2. Is we need any subscripts here? No. And water is just H2O. Everybody knows why. All right, this is a tough one to balance. Who can figure this one out? What do I need to balance this guy? Nothing at all. And that will happen. Okay? I have 1 calcium here. I have 1 calcium there. How many O's do I have on that side? 2. And I've got 1 O here and 1 O there. That's 2. 2 H's, 2 H's. It's done. It's already done. Don't have to do anything. So, by the way, remember I showed you the sheet, the test a little while ago. Here it is again. Okay? There are 14 on the test. Some of them, like this, won't even need to be balanced. At the end of the day, of those 14, for different reasons, you'll probably only have to balance about 9 of them, maybe 10. All right? And you know how much balancing is worth? People will always do this, because we are going to get some harder ones to balance, the next one being an example. People will say to me, oh, I'll never be able to, I don't understand, I can't balance, I'm going to fail. You're not going to fail for not being able to balance these. You know what you'll get if you don't balance any on the test? Your grade will be? Well, there's 9 of them, right? I told you they need to be balanced about. You need to get a 91. Balancing is worth 1 point out of these problems. And there are 14 on the test. Balancing, and of those 14, some don't need to be balanced. And others, there's another reason they don't need to be balanced, because they don't work. So between that, you get a 91 on this test, which with the curve, with your weight, is a 95. No one's failing this test because they can't balance equations. That would be nice if you can balance the equations. But I don't ever want to hear that for the next week. Oh, I can't balance these, I'm going to fail. You may not be able to ever balance very well, okay? But that's not a reason you're going to fail this test. It's not going to be the reason you fail the test. You will fail because you can't tell me what kind of reaction is and then finish it. You can't write the correct formulas like you couldn't write them last time. That will cause you to fail because that's worth a lot more points than balancing. All right, let's get to the next one. Try this guy. Potassium chlorate yields. Now, I want you to do this entirely on your own. From start to finish. Try it. I would hope you all have that much by now, right? That was the first step. You all get that much, right? All right. Keep going.
If we say it's an oxide rather than
Ooh, there's another one. I almost forgot about that one. Marvin's, great job, great mistake. You know how many people on that test wrote for potassium chloride, which was one of the questions somewhere in the middle there? PCl. You know how many people did that? And you say, well, it's no big deal. Actually, it was a huge deal because if you looked up P, his molar mass wasn't the same as K. It wasn't just that you used the wrong letter. You used the wrong molar mass, atomic mass. And therefore your molar mass was wrong, and therefore your conversion was wrong. P, and I had to see that at least 4 or 5 per class. People did that. Potassium's not P, people. It's K. But great mistake. Glad you made that. Okay, you're all working on this, I hope?
Yes, sir.
Correct. You got that for potassium chloride, I hope? Right? KCl? And did we so soon forget that O is O2?
No.
I'm sure people did. Okay? Now, once I know that that's correct, I still have to balance this guy. The K's are okay. Okay, K? CLs are okay. But my O's are not. So I'll just make this guy a 3 and then I'm all balanced, right? If only it were that easy. It's still a 2, guys. I have to balance it without changing his subscripts. I got 2 O's here, although it looks like a fish. I got 2 O's here, and I've got 3 O's over there, so I'll put a 3 here and a 2 here in front of the whole thing, right? Does that give me 6 O's on both sides now? Yes. But is everything else okay? No. I need a 2 in front of the KCl. Nice.
2.
Now, let me go on to the next one. But let me just say something about this next one. If you look at your sheet, what's my next one going to be? Acids. Look what I'm going to write here, guys. You can write this on your notes, too, to remind you. These guys are not going to, acids are going to be a whole chapter separate unto themselves. Acids and bases. So I'm going to just leave that go until then. We'll talk about acids much more in the future. You don't even know how to name them yet. Okay? They're a real pain in the acid. Okay, number 5. What does number 5 say? Now, number 5 and 6, I'm going to combine into one demo and one example. Okay? The demo is right here. I'm doing it. What is water? Isn't water an oxide? Isn't it hydrogen oxide? Right? And what does number 6 say? No, I didn't. What does number 6 say? Electricity. So that, what I'm doing right over there, okay, I'm going to look at it again in a second, is what I'm going to do right here. For 5 and 6, combine them together and show you that. Do a little demo on it. Okay? I'm going to shut it off now and show you what we've got. All right? Now I'm going to just turn off the power and not kill myself. Because all I did was pass electricity through this thing. And if you look at it now, turn that light on. If you look at it now, I don't know how well on the video you can see this, but I'll move it up relatively. Don't want to move too close. Yeah, I know. Put it down here. Yeah. Too low. Ah, there we go. That's a little bit better. Yeah, you still can't see. Moving it up. Okay. Now, if I look at this, right here is the level of the water, which means I collected that much gas on this side. This one's way down here, okay? Right down here. So I collected that much gas on that side. This much gas versus that much gas. I'm going to talk about that. That whole time it was bubbling. I had the wires hooked up at the bottom, passed electricity through it, bubbled. That's what I got. Okay? See if we can't make a conclusion on that in a second. But let's start the problem here. What is water going to break up into? You can turn the front light off again. What's water going to break up into? Tell me. Finish the word equation. What's it going to break up into?
H2O.
No. Finish the word equation. What's it going to break up into? This is an amazing thing. So our 6th example, well, not really. Our
Hydrogen and oxygen.
hydrogen and oxygen. Correct. Okay. You're not going to write the formulas first. You're going to write the names first. Hydrogen and oxygen. Okay. Let's finish this problem. Then we're going to go back and do a little test on that and see how well we did. Can you write the correct formula for water? I certainly hope so. H2O. Can you write the correct formula for hydrogen? What is it?
H.
It is not H. It is H2 because he's another one. He is the cashew. He is the ha in Brinkelhof. Brinkelhof. He's the ha. And the in Brinkelhof is. So he is also O2. Okay?
Dude, did we ever learn that?
No, we never learned Brinkelhof. Never used that before. Never talked about it, as a matter of fact.
Yes, we did. I watched it on the video.
I don't remember.
Thank you, Jared. See, this is the nice part. Honestly, Jared, not only that Jared's the nice part, because we all know you have to go to Jared's. But the nice part is, Emily, in years past, although Emily's probably only semi-serious, in years past, people would argue with me that I never said that.
I don't remember Bringle.
That's nice, but now there's video evidence. Video evidence that I know that I did say it, and you know that I did say it.
I don't even know if you. When was that? Like a week ago?
Emily, it's like arguing that if I drop this pen, it's going to go to the ceiling, and then when I drop it, it goes to the floor. Well, I think it should have gone to the ceiling. That's what you're doing right now. There's no debate. It happened. We're not debating something that I can prove by saying it.
Wrinkle off.
Oh my gosh. Anyway, look at. So how am I going to balance this? How am I going to balance this? I'm just going to put a 2 there, right? Can't change subscripts.
2H2O.
So I'm going to look, watch. How do I balance this guy? I got 2 H's. I got 2 H's. They're okay. I got 2 O's. I only have 1 O. Can't just change it to a 2 because I want it to be. I put a 2 in front of it. But that screws up my H's, so I need a 2 in front of that one too.
Wrinkle off.
Wrinkle off. All right. Now we're coming back to our thing here. Look at that board. Can you tell which side is hydrogen gas? Turn that light on for me, John. And which side is oxygen? If we look at this again, I'm going to say it to you again. I'll bring it up a little closer. Huh? Okay. Now, I know it's hard to see for our studio audience, but that's how much gas we have here. And we have it down to here on the other one. See it? So we have way more gas here. Matter of fact, we have twice as much gas here, right, than we have here. That's a hint. Which side, the right or the left, do you think is oxygen?
Right.
They think this side's oxygen because we have half as much as we have of this side. Can we test that?
Probably.
Yes, we can. How can we test it? Have we done this before? We did it. You did it yourselves. What if I collect some of that gas? What's a test we did in lab about oxygen? What will oxygen do if I give you a test tube and one of these? Yeah. What am I going to do with it? What will I do with the? What am I going to do with this wooden stick? Light it on fire, blow it out, and then what? Stick it in here. Okay, I'm going to need a little help because I can't do both at once. All right, so Ben can come up and help. That's a mistake, I know. It's okay, I'm going to pick Emily for the next one. Then we all know what's going to happen. And Emily will get to be on TV. That's a good one. Okay.
I like my eyebrows.
I don't want to sit
Yeah.
up front. I don't feel safe.
Well, let me grab a little bit of this. You have to do this. Here, I'll light that. You don't have any goggles on, so I'll light it. And you're just going to hold that for me. I need help here. All right. Now you are going to light this and then blow it out. But not yet. Not yet. Wait a minute.
He's gonna mess it up and like blow up the whole.
Okay. Now I'm going to watch how I collect this. If I turn this little stopcock, it will raise up to the top. And I'll put my hand over the top. Okay. You light that up. Let it burn for a little bit. Take it out of there. Let it burn a little bit. And then we're going to do it over the camera here. Okay. Blow it out. Now put it in while it's and then back out. Oh, you broke it! That's a mistake. All right, try it again. Maybe we still have enough in there. Let it burn a little bit. Let it burn, let it burn, let it burn. Burn, baby, burn. In and out. Oh, there he goes. Read it. Yeah, look at that. Beautiful. Okay, blow it out and run the water under it. Don't kill anybody. Okay. Now, Emily's going to come up and do the... No, don't run the water. Sorry, forgot about that. I got my wires in there. Sorry. It's okay. It's not connected to anything. It's just now that it's wet.
Dude, I knew I'd guess.
Good job. You didn't kill anybody. You didn't set anybody on fire.
But now Emily's here. So. All right, Emily. Let's try this one. Your same thing. Just listen to what I say. Here, you'll get in the picture. Don't worry about it.
Okay. Is my hair gonna catch on?
You're gonna need to light this. Just put it anywhere. You will need to light that again. Now, you did not see this test, but this is the test for hydrogen. You'll get here. Don't worry. You're gonna go over here. All right. The test for hydrogen is a little bit different. You don't blow out the thing. You simply put it over the top. So let me show you. So you listen.
Okay.
You don't go like this. You're just going to put it right over the top like that.
Can I touch it to the thing or no?
Just right over the top like that.
Touch
And
it to
hold
the
it there. Yeah, hold it right to the glass while it's still burning.
Okay,
Okay.
done.
You ready? Now hold on. Wait. Let me collect it.
I don't like love in my face.
Okay. You ready? Light it. Let it burn a little bit.
Love in my face.
Okay. Now don't blow it out this time. You ready? All right. Go ahead. Oh my God! That's good. Now you're blowing it out. Scare you? Yeah. Okay, now Emily's got to change her pants, so we're gonna hold that. Now you wanted to be on camera, and now you're wet. So that's what happens when you.
4 seconds of fame.
This one's not going to make YouTube probably. But, okay. All right. Very good. No, I'll put it up. All right. So you were right.
That's pretty good.
I'm definitely going on that.
You couldn't see me.
Turns out you were right. We did test the right ones. One came out to be oxygen, one came out to be hydrogen. Notice there was twice as much of the hydrogen, as you'd expect, turn that off, as you would have of the oxygen. Okay? And
I'm gonna start breathing.
that's what you'd expect.